Hi to all. In the last video we discussed about Thevenin's theorem, how to solve Thevenin's theorem, what is Thevenin's theorem, where we are applying, how to calculate power loss and current through any resistance in any linear bilateral network. We can use Thevenin's theorem. Now we go for Norton's theorem along with statement how to solve the problem, what is Norton's theorem. The Norton's theorem, let us discuss about that. Norton's theorem. The Norton's theorem named after E.L. Norton, one of the engineer at Bell Laboratories in USA. E.L. Norton, he found that E.L. Norton, one of the scientists and engineer, he named after that developed this theorem, Norton's theorem. Hence E.L. Norton developed, it is known as Norton's theorem. It is similar to Thevenin's theorem but small modifications. In Thevenin's theorem we are using Thevenin's voltage in series with Thevenin's resistance. Here we are using Norton's current IN and in parallel with Norton's resistance. It is quite opposite of Thevenin's theorem, and where we want to calculate current through any resistance that is connected, it is known as Norton's equivalent circuit. Thevenin's theorem lo voltage source and Thevenin's voltage will be there and in series with Thevenin's resistance. In Norton's theorem we have a current source, Norton's current source in parallel with Norton's resistance. Whatever be the linear network, suppose if it is a total network consists of A and B, between the terminals A and B, if the circuit is like this, where we want to measure the current, that may be assumed as load. It is known as linear network. Linear network with voltages and currents. If a circuit consists of linear network and voltages and currents, then the current through any resistance can be clubbed together by converting any circuit into like this Norton's current and Norton's resistance. How to calculate Norton's current, how to form a Norton's current, Norton's equivalent circuit. Norton's equivalent circuit lo Norton's current in parallel with Norton's resistance. ఇవే ఉంటాయి. అదే థెవెనిన్స్ అయితే V Thevenin R Thevenin సిరీస్లో ఉండే లోడ్ రెసిస్టెన్స్ ఉంటుంది. థెవెనిన్స్ థియరంలో ఈ విధంగా ఉంటుంది. V Thevenin is the Thevenin's voltage and R Thevenin. In Norton's we have Norton's current in parallel with a resistance, Norton's resistance. Now we go for what is the statement of Norton's theorem. Statement of Norton's theorem. Statement of Norton's theorem. Let us discuss now. What is the statement of Norton's theorem? In any two-terminal linear bilateral network containing a number of voltage sources and resistances can be replaced by an equivalent circuit consisting of a current source IN in parallel with a resistance Rn. A current source in parallel with resistance Rn. That is, current source may be represented as Norton's current and resistance may be represented as Norton's resistance. How to calculate IN? What is the statement? First, any two-terminal linear bilateral network in any two-terminal linear and bilateral network containing a number of voltage sources and resistances can be replaced by an equivalent circuit consisting of a current source IN in parallel with resistance Rn. This is the statement of Norton's theorem. Any linear network can be converted into one circuit, that is Norton's current is in parallel with resistance, Norton's resistance. Current source is in parallel with Norton's resistance. How to calculate Norton's current? How to calculate Norton's resistance? IN is known as Norton's current. This is the short circuit current supplied by the source. It is also called as Norton's current, ISC. Rn is the Norton's resistance, the equivalent resistance similar to Thevenin's resistance. How to calculate Thevenin's resistance? The same principle we can apply for this also. But how to calculate this IN? That is important. What are the steps to follow for Norton's theorem? Let us discuss now. What are the steps to be followed? First we have to calculate Norton's current, Norton's resistance. After calculating those, we can calculate current through any resistance. The first step is steps to follow Norton's theorem. What are the steps to be followed? Let us discuss now. In order to determine current through any load resistance, any resistance, in order to determine current through any resistance RL connected across the terminals AB as shown in figure. Previously, suppose in order to, if any circuit consists like this, it is a total resistance or equivalent circuit will be like this. This is the any network, voltage source, current source, all this will be. For this current through this, if you want to calculate, it acts as RL. It acts as RL. The first step is steps to determine Norton's equivalent circuit. The first step is short circuit across the terminals A and B. Suppose if you want to calculate, suppose if it is a resistance, another resistance, it is a voltage source, if it is another resistance, if it is another resistance. Assume that it is 6 ohm, 4 ohm, 3 ohm and 1 ohm. If it like that. Current through 1 ohm if you want to calculate. Current through 4 ohm if you want to calculate. First we have to, first step 1. Step 1 is short circuit across the terminals A and B. Suppose if you want to calculate current through 1 ohm resistance, short circuit we have to do. That is step 1 is short circuit across the terminals A and B. The terminals A and B. Assume that this is the terminal A and B. Previously how we discussed, this is terminal A and B, Norton's theorem. In this, if we want to calculate current through RL means whatever be the resistance. Short circuit across the terminals A and B and calculate current through IN. The calculate current IN we have to calculate, Norton's current. Short circuit across the terminals A and B. Suppose the circuit is like that, plus and minus some voltage and 10 volts or 5 volts like this. We want to calculate current through 1 ohm resistance. For that we have to calculate Norton's current. First step 1 is to find Norton's current. Norton's current ఇక్కడ పోయే కరెంట్ కనుక్కోవాలంటే ఫస్ట్ మనం నార్టన్స్ కరెంట్ కనుక్కోవాలి. ఎందుకంటే ఈక్వివలెంట్ సర్క్యూట్ నార్టన్స్ కరెంట్, నార్టన్స్ రెసిస్టెన్స్ రెండు ఉన్నాయి కాబట్టి. నార్టన్స్ కరెంట్ ఎప్పుడు ఉంటుంది? షార్ట్ సర్క్యూట్లో కరెంట్ ఎక్కువ ఉంటుంది, ఓపెన్ సర్క్యూట్లో కరెంట్ 0 ఉంటుంది. కాబట్టి ఇక్కడ మనం షార్ట్ చేయాలి. దట్ ఈస్ షార్ట్ సర్క్యూట్ అక్రాస్ ద టర్మినల్స్ A and B. Remove the 1 ohm resistance and short circuit it. Next, second step is, step 2 is find Rn, Norton's resistance of the network as seen from the terminals A and B. By seeing the terminals A and B, we have to ఇక్కడ నుంచి చూడాలి. By seeing the terminals A and B, by removing RL should be removed. Second step is to find Rn of the network. Norton's resistance we have to calculate for this circuit. To find Rn, the network as seen from the terminals A and B, if the terminals A and B are this, by removing RL, we have to remove the load resistance. From that, Thevenin's ఏ విధంగా అనుకుంటారు, by voltage source will be short circuited by internal resistance. After that we are calculating Thevenin's resistance. Similarly, by open circuiting the load resistance where we want to calculate the current, after that we are calculating Thevenin's resistance. Similarly, we are calculating Norton's resistance is similar to Thevenin's theorem. After calculating Rn, Norton's current, it is similar to Thevenin's theorem. If you know Thevenin's theorem, how to calculate Thevenin's equivalent resistance, then you can calculate Rn. Rn is also known as Thevenin's theorem. Thevenin's resistance also. Step 3, from the step 3 is draw the equivalent circuit. Draw the equivalent circuit by replacing the entire network by a single current source IN and parallel with a resistance Rn. From that, IL equal to IN into Rn by Rn plus RL. Rn plus RL. We have to draw the equivalent circuit like that. IN in parallel with Rn in parallel with RL. It is RL. Now, what is the current through IL? That is IN current into opposite resistance is Rn. Rn total resistance is Rn plus RL. How to current divide total current into opposite resistance by Rn plus RL? Based on this, we have to do like this problem. If you do one numerical problem, you can understand Norton's theorem easily. Total circuit representation regarding Norton's theorem is like that. Whatever be the circuit is given, R1, R2, R3, R4, R4 resistors a circuit consists. To find current through any resistance, any branch is R4 or RL. Assume that the current through resistance R4 we want to calculate by using Norton's theorem. First, the circuit will be reduced. In the step 1, we have to short circuit the resistance R4 which acts as load. The resistance R4 is short circuited. First, we have to short circuit where we want to calculate the current. After that, we have to calculate Norton's current. The Norton's current we have to calculate. Second step, we have to calculate Thevenin's resistance. Similar to Thevenin's resistance, we have to calculate Norton's resistance by short circuiting the voltage source. That is step 2. By seeing the terminals A and B, looking forward, after that we have to calculate. If you see this like this, Rn, how to calculate Rn? Similar to Thevenin's resistance. The R1 and R3 are parallel and R2 is in series with this parallel combination. Hence, the Rn equal to R2 plus R1 R3 by R1 plus R3. The parallel combination of R1 R3 is R1 R3 by R1 plus R3. Like that we calculated Rn. We calculated IN. Now the equivalent circuit of Norton's equivalent circuit is a current source is in parallel with a resistance, Norton's resistance and Norton's current, and it is in parallel with load resistance. This is the after finally we are forming the entire circuit into like this. After that we are calculating what is the current in load resistance or R4. That is the Norton's theorem. Let us solve by numerical problems, then you can understand easily.